Welcome to Algebra 2. We are looking at 2.2, solving absolute value equations. So what we need to know here is just what is absolute value. So that's what this first diagram here on the left side of the screen is going to help us describe and learn about. Well, absolute value, first of all, just takes something inside of these bars. Okay, those are absolute value signs. For example, if we took absolute value of 14, let's figure out what that would give us. Well, absolute value has a definition, and the definition of it states it's a measurement of distance from 0. So if I have 14 on the number line, and I take the absolute value of that, it's just asking me how far away from 0 is that? And that's 14 units. But realize that's not the only thing that is 14 units away from 0. The other value that's 14 units away is negative 14. So for example, if I took the absolute value of negative 14, it's asking me what is the distance of that to 0? Well, the distance of that to 0 is still 14 units. Notice absolute value makes both those values positive. The reason it does that is its distance. The distance is always positive. You never measure distance to be a negative number. So that starts to lead us into this next idea. Now we have 2x plus 12 equals 14, and we need to solve that. Well, we have 2x plus 12 stuck inside of these little bars, right? Stuck between the barriers, if you want to call it that, or the absolute value bars, but it's stuck inside of that. So the first thing we need to do is get rid of those bars somehow before I can move the 2 and the 12. Well, in order to do that, we can use our definition. I know this is the distance, where whatever the distance is, it has to be equal to 14. Well, there's two ways that the inside could give you a distance of 14. You could say that the inside of it equaled positive 14, and the distance between 14 and 0 is 14. And the other thing you could say is the distance between 2x plus 12 could also be at negative 14. Because if I took the absolute value of negative 14, that would still give me a distance of positive 14. Well, once you separate those, notice the bars are now gone. You create two equations to get rid of those bars. And now you just solve both of those. Move whatever adds or subtracts first generally, and then we can divide by 2 on both sides and find our answer. Realize the process for these is the exact same, right? I'm subtracting, I'm dividing, but the way that your answer changes on the right side is because the signs were different. We just found both of our values. The next thing we can look at then is another problem, but notice on this next problem now, we have 6x minus 1 equals negative 7, this equation right here. Well, again, absolute value is a distance, so this is telling me we have a distance. But notice they're saying this distance has to be negative 7 units away from 0. Okay, but that frustrates me now, right? Because you just said distance has to be positive. Well, we just said the distance is negative 7. How does that work? Well, the answer is it doesn't work. You can't take a distance and make it negative. So if this ever occurs, what you get is no solution. Realize you can only say that you have no solution when there is nothing outside of those absolute value bars. Let's see what I mean by that on this next example. Notice we have negative 28 on the other side, and we might be thinking, okay, that tells us right now that this equation has no solution. But that's not necessarily true. The first thing we need is this box, the absolute value bars, to have nothing outside of it. So what we need to do is we need to start to move the things on the outside to the other side of the equal sign. And just like you would do if you had an equation like this. If you had this equation instead, you would probably move the 18 first to the other side and then move the 2. Well, we can do that same process here. Move whatever adds or subtracts first, so I can get rid of the 18, giving me negative 46. But again, the absolute value is not by itself yet, so we still need to do that. Well, I have this negative 2 out front. How can we move that? Well, since the negative 2 is next to the bars, right, there's nothing in between the 2 and that bar. That means they must be multiplying together. So to get rid of that multiplication, you can't necessarily distribute it to the inside, right? A lot of people want to take this 2 and multiply it to the inside. But that's not possible because these are absolute value and not a parenthesis. So there is no distribution to the inside. But it's a good idea because, sorry about that. It's a good idea because that negative 2 is multiplying. We just need to get rid of that multiplication. So let's divide on both sides. 9x minus 4 is now equal to 23. Notice those bars are now by themselves like we wanted. Because they are by themselves and it is now equal to a positive value, we can continue our process we learned on the first two problems. That process was... Sorry about that interruption. They just had to use the PA system. So from here, and again. All right, let's try that one more time. So sorry about those interruptions. Let's continue this problem. So 9x minus 4, right? There's nothing else outside of the bars. So now we get rid of the bars. And remember, to get rid of the bars, we said what you need to do is create two equations where the distance is 23. Well, we know there's two cases that happens. The distance could be at positive 23 or it could be at negative 23. They both have a distance of 23 units from 0. And then you're just solving. Okay, so we'll just do that super quickly and you'll see how we get two answers. This one looks like it will come out as a fraction. That is okay, though. We can just leave it as that fraction there, negative 19 over 9. So that is the idea that we're looking at. And what we can do is we can make that more challenging. We can get to a problem that looks like this, where there's a lot more steps. Well, there's still steps that we know, though. We still know we need the bars to be by themselves, so anything on the outside you move, and we generally move what adds or subtracts first. So, okay, now make sure the 9 combines with its like term, right? The 4 has an x, so it won't add with that. It'll combine with the 17 because that's its like term. We can still get rid of the 2. Again, you have to divide it on both sides. And when you do that, one thing you do want to note is multiplication and division affects everything. So if I divide by 2, the 2's on the left cancel, but the 4 and the 26 both get divided. So finishing that problem then, 4 divided by 2 is 2x. 26 divided by 2 is 13. Oh my goodness. These announcements are killing me. All right, continuing again. So now we have the bars. We need to get rid of the bars. And we created two equations. So first equation, 5x plus 1. And we just needed that to be the same value that we had before, right? On that last problem, the 23 stayed the same for one of those equations. So on our problem, the other side of the equation, the 2x plus 13, is still going to stay the same. The weird thing, though, is when you create the other side of the equation, we take the 5x plus 1, and now we need to change the signs, right? We had positive 23. We flipped it to be negative 23 on the last example. Same thing here. Change the sign on the 2, change the sign on the 13. That does not just mean make both of them negative. It means change the sign. So if one was negative, you would make it into a positive. From there, just solve both these equations, get your variables on the same side, and then solve super, super quickly. Once you do that, you have your final answers. And then there's a weird part we haven't necessarily talked about in class, so we will save that for another time when we get to extraneous solutions eventually. So, how many times? All right, trying to finish this video with no more interruptions. We end up subtracting on both sides, negative 14, divide by the 7, and now you have your final answer. It looks like negative 2. Okay, again, we're not going to talk about extraneous solutions just yet, but this is just setting up the idea of how to solve all of these complicated problems, and we'll get to that down the road. Again, sorry for all the interruptions. This is video 2.2, solving absolute value equations.